Breaking news tonight as quantum AI scans have confirmed that interstellar object 3I/Atlas is not natural at all.
Humanity faces a cosmic threat like never before. 3I Atlas, an interstellar object, has changed course in a way no natural body should. It's moving faster than anything we've ever seen. Its light pulses carry strange signals, and now it might be on a path toward Earth. Scientists are racing to understand it, but answers are scarce. Is this a random asteroid or a visitor with intent? Stay with us, because what comes next could change life on our planet forever. The signal that wasn't supposed to exist. The first alert came not as a blaring alarm, but as a faint anomaly on a screen in Hawaii. Deep space monitors, scanning the endless black for tiny fluctuations, picked up a series of luminous pulses that repeated with uncanny regularity. At first, the team assumed it was a glitch, electronics misfiring, cosmic interference, or software error. Days passed, and the pattern persisted, growing more defined and almost musical in its cadence. It was a signal that refused to be dismissed, whispering from a distance of billions of miles. Across the globe, observatories received mirrored data. From Chile to the Canary Islands, astronomers noticed the same precise pulses. They were tracking a point of light that did not belong. Brightness fluctuated as if the object were alive in its movement, yet no natural comet, asteroid, or planetary fragment could behave this way. Researchers pored over the numbers, calculating trajectories and velocities, only to discover that it did not match any known model. It was as if the universe had inserted a new rule into the celestial order, and humans had only just caught its signature. In laboratories lit by the soft glow of monitors, scientists debated the implications. Harvard and MIT ran simulations that contradicted each other. Data showed velocity far beyond what a typical interstellar visitor should exhibit, yet its spectral signature suggested a dense, reflective surface rather than frozen gas or dust. Engineers speculated about mirrors, ice-coated surfaces, or unusual mineral formations. None of their hypotheses fully accounted for the way light ricocheted off the object, nor its ability to maintain a perfect rotational cadence across months of observation. Meanwhile, communications teams struggled to broadcast findings without inciting panic. The object had been cataloged as 3I Atlas, the third interstellar visitor detected in human history, after Oumuamua and Borisov. Both predecessors had intrigued astronomers, but posed no immediate threat. Atlas was different. Its trajectory was hyperbolic, its velocity unmatched, and its brightness varied in ways that suggested intentional modulation. Some whispered that it was not merely passing through, but sending a subtle message through the way it reflected sunlight, a cosmic Morse code too slow and dim for casual observation. The human dimension of the discovery added another layer of tension. Night after night, teams of astronomers slept fitfully, staring at screens, analyzing fluctuations measured in thousandths of a second. Emails flew between continents, hypotheses building upon hypotheses, theories rising and collapsing like waves. The excitement was electric, but so was the unease. Atlas refused to follow any natural pattern, challenging centuries of accumulated knowledge about how the solar system functioned. For the first time, the sky felt unpredictable, and the familiar sense of cosmic order seemed suddenly fragile. By the time the world noticed, social media had begun buzzing with speculation. Amateur stargazers shared blurred images, while experts remained cautious, aware that premature announcements could spark fear. Scientists emphasized caution, yet they could not hide the truth. The object's arrival defied everything they thought they knew. Its precision suggested intelligence, design, or some unknown natural law that had yet to be discovered. Even the skeptics paused, the usual rational explanations losing weight in the face of accumulating anomalies. As the pulse sequences continued to stream in, a quiet tension settled across observatories worldwide. Atlas moved as if aware of the eyes tracking it, obeying physics while challenging assumptions. Each flash of light seemed to ask a question, and humanity did not yet know the answer. The universe had spoken, faintly and deliberately, and the message carried implications far beyond mere curiosity. Could a visitor from another star system carry more than debris and ice? Could it carry intent, purpose, or observation aimed squarely at our fragile planet? What if the first messenger from beyond the stars is not just a visitor, but a harbinger? Stay with us as the mystery deepens. The object that refused to behave. When astronomers refocused their telescopes on Atlas, the object revealed a behavior that shattered all expectations. Its glow did not diffuse like cometary dust, but shimmered in sharp, irregular flashes, reflecting sunlight as if coated in polished facets. Observers noted that these reflections aligned with its rotation, creating a rhythm so precise it suggested deliberation. Satellite imagery from orbiting observatories confirmed it. Atlas moved with an order that defied natural randomness. Spectrographic readings delivered further surprises. The light emitted from the object carried subtle color shifts, hinting at materials unseen in typical solar system bodies. Metals, perhaps, or compounds still unstudied, interspersed with ice in patterns that seemed almost engineered. Every oscillation of brightness, every slight change in hue, carried data too complex to be accidental. Scientists began speculating. Was the object a probe, or merely an artifact of an unknown cosmic process? No theory could fully encompass the observations. As global teams shared images, an unsettling realization spread. Atlas's path through the sky appeared to anticipate observational efforts. When a telescope aimed for precise tracking, the object would subtly adjust, never drastically, but enough to render high-resolution imaging difficult. It blurred slightly in long-exposure photographs, as if refusing to be fully captured. Engineers joked nervously about shy asteroids, but even they recognized the anomaly went far beyond quirks of light or instrument error. Something was interacting with the act of observation itself. The rhythms in Atlas's glow became a puzzle in their own right. Harvard researchers detected a near-perfect periodicity, a cadence that repeated every 7.2 hours, aligning with no known rotational period for a body of its size. The discovery prompted heated debate. Could the rotation be artificially regulated? Could natural forces, solar wind, gravitational tides, produce such symmetry? Calculations showed they could not. The patterns were deliberate, intentional, precise. Meanwhile, Atlas's motion through space continued to defy precedent. Unlike prior interstellar visitors, it did not tumble erratically or succumb to the sun's gravity. Its orbit remained stable, almost poised, as if it had charted a route through centuries of celestial dynamics. Analysts found this especially perplexing. If it were a natural object, countless minor collisions or gravitational nudges would have altered its course. Yet it navigated with unerring accuracy, maintaining speed and alignment in ways that suggested planning rather than happenstance. Observatories began noticing something else: faint radiation spikes coinciding with the object's reflective flashes. The pulses were weak but detectable, hinting at energy emissions inconsistent with normal cometary behavior. Some suggested charged particle interactions, others unknown electromagnetic phenomena. Across continents, scientists ran simulations testing every natural explanation. Each model failed. The more humanity scrutinized Atlas, the clearer it became that the object was not merely passing through. It seemed to exist in a different class entirely. For the first time, the word intelligence crept into research papers and private notes. Not definitive, not proven, but whispered in emails and conference calls. The idea was dangerous, implying purpose, hinting at observation, suggesting contact beyond Earth. The world remained oblivious for now. But within the astronomy community, speculation mounted. Atlas had become more than a visitor. It was a question without an answer, a cosmic riddle designed to provoke awe and fear. As the sun dipped behind observatories in Chile and Hawaii, the object's light grew sharper, brighter, almost as if responding to human attention. Every detail observed deepened the mystery, and the astronomical community realized that Atlas was not just an anomaly, but a herald of uncertainty. Humanity was witnessing a force that obeyed the universe's rules while simultaneously bending them. A cosmic presence whose intent remained unknown. Could an object this precise be indifferent to life, or was it deliberately observing us? Come with us to explore the hidden corners of the story. The path that knows our name. The calculations arrived with sudden clarity, and then the dread followed. Orbital models confirmed something astronomers had barely dared to suspect. 3I Atlas was not drifting at random. Its trajectory traced a near-perfect alignment with the plane of the solar system. Every planet's orbit formed a silent guide, and Atlas moved in tandem, as if weaving through invisible corridors. Observers realized this object was not just passing, it was navigating, threading through billions of kilometers with meticulous intent. What baffled scientists most was the tilt. Unlike ordinary interstellar objects that arrive at odd angles, Atlas's path tilted only 5 degrees relative to the ecliptic plane. For natural objects, such precision was astronomical improbability. Mathematicians pored over millions of possible permutations and found none matched this combination of speed, angle, and approach. The universe, they concluded, had folded a rare hand, but Atlas played it with a certainty that felt almost intentional. Further anomalies emerged when they traced its orbital mechanics backward. For centuries, Atlas had moved counter to the flow of planets and asteroids, against the predictable rotations of the solar system. Unlike comets captured by gravity or redirected by solar tides, it had not been pulled into the chaotic currents of the Kuiper Belt. Its reverse motion was subtle yet unmistakable, like a figure moving upstream in a river of stars, deliberately resisting forces that shaped every natural body in its path. Experts began to whisper it was choosing its journey, not letting chance dictate the route. Atlas's path defied expectations. Even Jupiter's massive gravity barely affected it, and Pluto's pull was negligible. Calculations showed that small deviations barely altered its trajectory, suggesting the object adjusted itself almost as if it were aware of planetary positions. The likelihood of a collision with Earth grew with each observation. Scientists also noted the precision of its approach. Unlike natural objects influenced by countless micro-asteroid impacts or solar radiation pressure, Atlas's path remained stable across weeks of measurement. Its alignment intersected Earth's orbital plane with uncanny accuracy. While predictions could not yet declare impact, simulations projected a scenario in which the crossing point coincided with human civilization's presence. A single error in estimation could mean millions of lives at risk. The cosmos had produced a mystery, and it had chosen a point in space where humans could see it arrive. Atlas's quiet efficiency sent ripples through the scientific community. Leading astronomers convened emergency briefings, grappling with implications. Was the object a natural anomaly, a probe from distant civilizations, or a harbinger of forces beyond comprehension? Every model reinforced the same chilling notion. It was not meandering aimlessly, but approaching on a path designed with deliberation. Researchers found themselves holding their breath while calculating distances measured in astronomical units, aware that their work might mark the first human confrontation with the unknown. As data streamed from observatories worldwide, astronomers noticed subtle accelerations and decelerations along the route. Though minor, these fluctuations were consistent across all tracking stations, eliminating observational error. Each adjustment made the trajectory increasingly earthbound. It was no longer a question of whether Atlas would pass by, it was a question of when and with what consequence. The silence of space seemed suddenly heavier, as if the universe itself were waiting for humanity to notice the inevitability of this visitor. The more they analyzed, the deeper the unease grew. Atlas moved like a chess player several moves ahead, countering forces that should have redirected it. Its passage across the solar system felt purposeful, deliberate, almost conversational. Humanity had long observed stars as distant ornaments, indifferent and eternal. Now one had arrived, and its path suggested it knew we were here, even if we did not yet know why. Was it truly chance that the object's path aligned so perfectly with Earth? Or was there intent behind its motion? Step with us into what no one ever saw coming. The speed that erased distance. The first realization came in numbers too vast to fully grasp. Atlas was moving at a velocity far exceeding any interstellar object previously detected. Instruments measured speeds surpassing 41 miles per second, nearly double that of any natural comet observed before. Unlike comets or asteroids that slowed as they approached the sun, Atlas maintained and even adjusted its velocity, resisting gravitational forces as if propelled by an invisible hand. Each calculation pushed the limits of accepted physics, leaving scientists both awestruck and alarmed. Its motion defied expectation in subtle ways. Ground-based telescopes tracked a blur that shifted almost imperceptibly, yet consistently, across the night sky. Long exposure photographs showed streaks that seemed slightly skewed, as if Atlas was anticipating the tracking efforts and altering its passage to stay ahead of observation. Analysts reviewed hundreds of sequences, noting that deviations in apparent speed never occurred randomly. Every adjustment appeared calculated, maintaining a course that could bring it closer to the inner planets with unnerving precision. The rapid transit through the outer solar system drew attention from spacecraft already in orbit. NASA's probes, Voyager, Juno, and New Horizons, captured fleeting glimpses, each registering readings that hinted at unusual energy emissions. While the object lacked conventional engines, subtle disturbances in the local magnetic field suggested interactions beyond normal physics. Instruments designed to measure solar wind fluctuations recorded anomalies aligned with Atlas's passage. The signals were weak but consistent, raising questions about whether it could sense environmental conditions and respond in real time. Timing became a critical concern. Every day, the object's closing speed shortened the window for accurate measurement. Scientists had to update calculations hourly, predicting not only position but potential trajectories. Minor errors compounded at extraordinary speeds. An underestimation of a fraction of a second translated into millions of kilometers off target. Meetings ran late into the night as teams cross-checked measurements, ran simulations, and debated new methods for anticipating its path. Humanity had never confronted an object moving at such scale, precision, and adaptability simultaneously. Even the atmosphere of observation seemed to shift. Amateur astronomers reported unexpected interference with imaging equipment during nightly tracking, phenomena that left professionals puzzled. No meteorological or electronic explanations sufficed. Atlas's rapid motion had introduced a variable that defied the usual parameters of measurement. Data streams from remote observatories required constant recalibration, highlighting the difficulty of comprehending a force that moved not just fast, but with intent. Meanwhile, scientific discourse grew urgent and speculative. The speed of Atlas suggested that its arrival in the inner solar system could occur in months rather than years. Astronomers discussed scenarios in hushed tones, examining potential interactions with planets, moons, and debris fields. If the object were purely natural, it would still be remarkable. If it were artificial, the implications were staggering. Theories proliferated, from unknown propulsion methods to entirely new physics, but none could fully reconcile the combination of velocity, course stability, and subtle adaptation. Observations revealed one final unnerving trait. Atlas did not leave a trail. Comets and meteorites scattered debris, even at high velocities, but no particles accompanied this visitor. Its path through the solar system remained clean, undisturbed, almost surgical. Analysts began to consider that the object's speed and composition allowed it to navigate without any detectable residue, further separating it from anything previously cataloged. It was an interstellar phantom, visible yet untouchable, moving at a pace that human technology could scarcely monitor. As global attention turned toward predictions, the world's awareness remained limited. Scientists realized that the object's closing velocity made every subsequent observation more critical. Each measurement was a fleeting opportunity, a chance to understand movement that defied expectation and hinted at intelligence or design. Atlas's speed was no longer just a number, it was a signal of urgency, a countdown ticking against time itself. The next revelation changes everything known about trajectory and control. Stay here as the next twist unfolds. The shift no one could explain. As Atlas approached the inner planets, an observation defied even the most advanced simulations. Midway through its path, the object altered its course, not by chance, not under gravitational influence, but with precision. Every orbital model showed an anomaly, a sharp, deliberate adjustment that did not correspond to any natural phenomenon. Instruments confirmed the same change across multiple observatories worldwide. It was as if Atlas had made a decision, a maneuver that no asteroid, comet, or fragment of rock could execute. Teams of scientists worked feverishly to verify the data. They ran simulations accounting for every conceivable force: solar radiation, gravitational perturbations, unseen planetary bodies, or even micro-collisions with interplanetary debris. None explained the sudden adjustment. Each test narrowed the possibilities, leaving one unsettling conclusion. Atlas had altered its trajectory autonomously, an action that defied all known physics. Even seasoned astronomers felt the quiet chill of witnessing something entirely unprecedented. The mechanics of the shift baffled experts. Analysis showed the object's angular momentum remained constant, while its path curved in a manner inconsistent with natural forces. Spectrographic studies before and after the adjustment revealed no signs of conventional propulsion, no gas jets, no plasma exhaust, nothing detectable. The movement was smooth, calculated, and intentional, suggesting some form of unknown energy or self-regulating system. For the first time, the line between natural phenomenon and artificial design blurred to near invisibility. Alongside the trajectory, subtle fluctuations in its reflected light were recorded. Observatories noted micro-pulses that synchronized with the course change, hinting at a connection between its structure and motion. It was as if Atlas communicated through the way it moved, each adjustment paired with a visual signature too faint for casual detection. Data analysts marveled at the implication, a celestial object capable of encoding information into its trajectory itself, a language of movement written across the solar system. The impact of this discovery spread quickly among global space agencies. Emergency meetings convened behind closed doors, with orbital engineers calculating the new probabilities. Even minor deviations mattered. A shift of a fraction of a degree at this speed could determine whether Earth would be missed by millions of kilometers or directly intersected. The mathematical precision required to model Atlas's next move left experts questioning whether the object simply obeyed physical laws or whether it understood them. Meanwhile, ground-based telescopes reported anomalies in other wavelengths. Infrared and ultraviolet sensors detected subtle thermal changes corresponding to the moment of adjustment, suggesting energy emissions without known sources. Even neutrino detectors registered faint signals coinciding with the maneuver, though inconsistent with natural cosmic events. The pattern was deliberate, traceable, and synchronous across multiple observatories, leaving a singular, unnerving possibility. Atlas was not only moving on its own, but somehow interacting with the environment in ways previously unimaginable. Public awareness remained limited, but whispers of extraordinary behavior leaked to the press. Scientists struggled to communicate the phenomenon responsibly. Even a hint of intentional movement could incite panic. Still, the evidence was undeniable. The interstellar visitor was not following nature. It was bending it. What had once been a distant object of curiosity now carried the weight of possibility. Its decisions, encoded in light and motion, demanded interpretation, and humanity was unprepared for the implications. As global observatories recalculated the object's new path, the question grew unavoidable. A single precise adjustment had changed everything, demonstrating that Atlas was more than a speeding rock. It was a force that could shape its own fate. Scientists now face the profound challenge of anticipating its next move without precedent or guide. If an object can steer itself across billions of kilometers, what does that mean for life on Earth? Stay with us as the secrets grow even darker. The silence before impact. By late November 2025, Atlas had entered the inner solar system, and its presence was no longer a distant curiosity, it was an undeniable threat. Telescopes captured its reflective surface growing brighter each night, while high-precision instruments detected minute interactions with the solar wind. These disturbances were unlike anything recorded before, subtle yet measurable, as though Atlas was testing the very medium through which it traveled. Analysts realized that even the emptiness of space offered feedback, and the object seemed to respond. Space agencies around the world scrambled to share data in real time. Atlas's passage triggered urgent recalculations of potential impact scenarios. Unlike prior interstellar visitors, its approach was smooth yet erratic in ways that defied prediction. It made no noise, left no debris, and avoided detection by radar satellites designed for smaller near-Earth objects. Each measurement exposed a new layer of mystery. Thermal fluctuations, faint electromagnetic pulses, and slight gravitational interactions with distant asteroids, all synchronized with the object's trajectory. In underground control rooms, teams of engineers and scientists worked tirelessly to simulate outcomes. Early models suggested a near miss, but updated calculations incorporating the latest anomalies indicated a potential intersection with Earth's orbit. The object's size, speed, and lack of detectable mass loss implied an impact could release energy equivalent to tens of thousands of nuclear warheads. This was no longer theory. It was the possibility of extinction-level devastation. Observers noticed patterns in Atlas's subtle light fluctuations. Unlike earlier rhythmic pulses, these signals were chaotic yet coherent, as if attempting to communicate beyond human comprehension. Standard frequency analysis failed. Teams proposed it might be transmitting information through micro-variations in reflection or electromagnetic interference, shifting the crisis from scientific to existential. Meanwhile, satellites monitoring solar activity reported unexpected disruptions. Atlas's passage caused minor perturbations in high-energy particles near Jupiter and the asteroid belt. These interactions were too weak to deflect it, but suggested the object responded to the environment rather than drifting passively. Every new data point deepened the mystery, reinforcing that Atlas was unlike any natural phenomenon. Global awareness grew as rumors of its behavior spread. Governments quietly briefed media and strategic agencies, yet the true nature of the threat remained abstract. People watched the night sky, unaware that a presence billions of kilometers away could reshape life on Earth. For many, it was a reminder of humanity's fragile place in the cosmos. As December approached, Atlas's trajectory brought it closer to Earth's orbital plane. Each calculation reduced the margin for error. The world waited in silent anticipation, knowing that observation alone could not prevent what might come. Humanity had gazed at the stars for millennia without expectation of reply. Now that gaze had been met, and the answer remained unknown. 3i Atlas is closing in, and the questions it leaves behind are terrifying. Will it miss Earth, or is our planet in its path? Observatories are watching, but the truth remains uncertain. What do you think lies behind this mysterious visitor from the stars? Share your thoughts below.